Your eyes and your vision are under attack, damaging blue light from the sun. Your phone, your computer, your tablet, even light bulbs and car headlights is constantly bombarding you. The good news is our eyes actually already have a line of defense to counter the effects of blue light. This defense is made up of 3 pigments called carotenoids. MacuHealth with Micromicelle, the only supplement with the exclusive patent on all 3 macular carotenoids and Micromicelle technology.
Do your patients know what presbyopia is?
There are people who are afraid of the press.
Have you talked to your patients about multifocal contact lenses?
I've heard the bifocal, but not multifocal.
Exactly, not multifocal.
Do you need help with your multifocal strategy? Learn more at the conclusion of this episode. With more screen usage and indoor time, myopia, also known as nearsightedness, is increasing and getting worse in children. Now, certified eye doctors can prescribe MiSight One Day, the first and only FDA-approved soft contact lens to slow myopia progression in age-appropriate children. Visit CooperVision.com to find a Brilliant Futures certified eye doctor near you. Hello and welcome to Open Your Eyes podcast. I'm Dr. Kerry Gelb, the host of the documentary Open Your Eyes. If you're new here and you like our interviews, press like, subscribe, share, and hit the bell to get notifications of great new interviews. Also, please leave comments. Great news, you can now watch our full-length documentary, Open Your Eyes, on Amazon Prime, Apple TV, iTunes, Google Play, and YouTube Movies and Shows. And tune into our brand new radio show Saturday mornings at 9 a.m. Central Time on AM 1280, The Patriot. Also, please share your thoughts by emailing me at drkerrygelb@gmail.com. That's drkerrygelb@gmail.com. And visit my website, drkerrygelb.com. It is well established that increasing proper dietary carotenoids, plant pigments, can decrease the progression of macular degeneration. But emerging research has now linked certain carotenoid dietary intake to better cognitive performance. Today's guest, nutritional biochemist, Dr. Elizabeth Johnson, PhD. Dr. Johnson did her postdoctoral research at Tufts University. Dr. Johnson has over 30 years of experience in the study of nutrition and healthy aging, with an emphasis on carotenoids and age-related visual and cognitive function, and has over 100 peer-reviewed publications, of which more than 60 are on the topic of carotenoids. Dr. Johnson, thank you for joining me today.
Yes, of course. I'm happy to be here.
Dr. Johnson, we're so happy you're one of the world experts on carotenoids, and most of the public doesn't even know what a carotenoid is. So tell us, what are carotenoids?
Well, this is a perfect part of the year to talk about carotenoids. If you live in New England like I do, and all the leaves are turning from green to red and orange and yellow, that red and orange and yellow, those are carotenoids. And carotenoids are plant pigments. So think of your tomatoes, think of your pumpkin pie, which we'll be thinking about next week, and think about your corn and your spinach. And now spinach isn't red, yellow, or orange, but if you leave it out in the sun and it starts to, deteriorate, what's happening there is the chlorophyll. Chlorophyll is green and it's breaking down to reveal those carotenoids. One of which is lutein, and that's the one that you'll find in spinach.
So lutein, what foods have the most lutein in it, would you say?
Well, if you look at your dark green leafy vegetables, like your spinach, like your kale, like your collard greens, those are all going to be very rich sources of lutein.
And if you cook these vegetables, do you lose the carotenoids? Do you increase it, or does it make no difference?
Well, actually, cooking's a really good thing to do. So when you think about the plant cell, it's different than the cells I have in my body because they have a cell wall. So when you cook it, you chop it, you juice it, you break that wall to allow those carotenoids to be released and better absorbed from your gut into your body. So actually, that's probably a good idea. Although I would never discourage someone from eating a spinach salad, because you're still going to get your lutein. You just might get a little bit more if you are going to cook that spinach.
And you brought up juicing. Is there a difference between juicing and blending? Do we even know?
I don't know. but I would think no, that with the really objective being to break down those plant cell walls. So if you're doing that, you're doing good.
And how many carotenoids are there in nature? How many are in our diet? How many get into our blood? And how many get into our eye?
Well, this is what I find totally amazing about lutein is when we look at nature, in nature, in any plant that's got these bright colors that are red and orange and yellow, there are about 700 in nature. And in our diet, we might be eating maybe 50, and about 20 get into our bloodstream, our circulation, and other tissues. But from that 700 down to the 50, down to the 20, down to the 2 that get into your eye, into the a part of your eye called the macula. And what the macula is, it's part of the retina. The retina is in the back of your eyeball. So when the sun comes in straight directly into your retina, dead center, that's where your macula is. And that's where lutein is. And the amount of lutein that's in the macula is about 500 to 1,000-fold more concentrated than anywhere else in the body. So to me, that gives some biological plausibility for it being important, not only because there's so much there in the macula, but it's where you want it to be. Because if you remember, I said the macula's dead center in the retina. Dead center in the retina means it's going to get a direct hit from sunlight. And think about that spinach salad in the sun turning, colors because it's getting destroyed. Same thing can happen in your retina with decades of light exposure. So to have something like lutein there in high concentrations is a good thing. Lutein's yellow, and the visible light that reaches your retina is blue light. Blue light is visible light. And because of those colors, the yellow and the blue, that blue light gets absorbed by the yellow light. So it can't go on further in the retina to those photoreceptors to cause damage, light damage. So that's one property of lutein. It absorbs the blue light, so it can't do damage. And it's also an antioxidant. So think of oxidation, that's usually not a good thing. Think of a rusty nail, that's oxidation. So antioxidant helps prevent that oxidation. And lutein does that. And the eye is very metabolically active. So it can produce some oxidation. So to have an antioxidant there is a good thing. And the epidemiology, that is when you look at large populations and what people are eating and what health outcomes they have or don't have, you find that the epidemiology really supports the idea of eating more lutein from your green leafy vegetables is associated with a decreased risk of age-related macular degeneration. So remember that word, macula, age-related macular degeneration, a major cause of visual impairment among the elderly. Because think about it, it's been decades of light exposure to that eye that with age, that's going to be a risk factor to something called age-related macular degeneration.
So the macula is about 5 millimeters of the eye in the central part of the eye. Now, you mentioned that the blue light is the only light that hits the back of the eye. People thought that UV light at one time would reach the macula. Does any UV light actually reach the macula?
That really, the lens takes care of that. I think that's where most of that happens. So that just like with macular degeneration, there is some epidemiology to support high intakes of lutein to decrease the risk of cataract, so lens cataract. And when you look at the carotenoids that are in the lens, lutein is the dominant one. So it's there too. So it's probably having a role there as well.
So there's been some studies that show that lutein, zeaxanthin decrease cataracts. And some of the research on that, what's your feeling on that?
Well, just like with the retina, being vulnerable to oxidative damage, the cataracts are too. And so again, cataract you think of as an age-related eye disease, right? Because it's decades of exposure to light, and you have these antioxidants in the lens that can help prevent that. And again, the epidemiology supports that.
And you talked about blue light before and being if there's enough pigment in the back of the eye, it'll absorb the blue light. How about if there's not enough? Are we going to get a lot of glare and scatter from the blue light? And will people have trouble with glare or sensitivity to the sun if they don't have enough of the pigment that the lutein makes to protect the macula in the back of the eye?
Yes, lutein does help with the glare, and those studies have been done and very well. I haven't done those studies, but my colleagues have, and they're well-designed studies. And a well-designed study is something where you have a placebo, so they're not getting this active ingredient, in this case lutein, and you have subjects that are getting lutein, and it's double blinded, meaning that the subjects don't know whether they're getting the placebo or lutein, and the investigator doesn't know who's getting what, or the people doing the test. So that's the gold standard of clinical trials. And in those studies, they find that supplementation with lutein actually decreases glare. So it's really an important thing. And as I get older, I'm noticing when I drive at night that I can tell that I have issues I didn't have when I'm younger. And I'm just a strong supporter of eating those green leafy vegetables to make sure that things don't get worse.
And before you mention the back of the eye, the macula, there's two carotenoids. But how do you add in mesozeaxanthin to make it three, lutein, zeaxanthin, and mesozeaxanthin, or is mesozeaxanthin just really part of lutein?
Yeah, we did that study because there was question, where does this mesozeaxanthin come from? Because if you look at what we're eating, there's not a lot of foods that contain mesozeaxanthin. It's mostly zeaxanthin and lutein, zeaxanthin, mesozeaxanthin. They're all isomers, which means they all have the same components in their structure, but they're just bent a little or twisted a little bit differently. So they are different. And when you look in the macula, you find that the composition of that, what we're going to call macular pigment, so lutein, zeaxanthin, and mesozeaxanthin, the composition in the macula can change depending on where you look in the macula. So the studies that we did looking at, where is this mesozeaxanthin coming from in the retina, since you don't really see it in foods so much. So we did that study where we fed monkeys pure lutein and pure zeaxanthin. And the reason we use monkeys because unlike your usual laboratory animal, the rat, the gerbil, the mouse, monkeys have a macula. These other more traditional laboratory animals don't have a macula. So that was a good model for us to look at what happens when you eat just pure lutein or just pure zeaxanthin in these monkeys that had never eaten a carotenoid in their life because of the design of the studies that they were in. And when we did that and then looked at what was in their macula, we found that those monkeys fed pure lutein, converted that lutein into mesozeaxanthin. Whereas those monkeys fed pure zeaxanthin, there was not any conversion. So yeah, that's where it's coming from. And when you look at the composition of zeaxanthin in the retina, about half of it is mesozeaxanthin, about half of it is zeaxanthin. So the retina seems to want mesozeaxanthin there as well as these other two macular carotenoids.
So the mesozeaxanthin is dead center in the macula of the eye, the center of the eye, the center 5 millimeters, the part that allows us to see. around it is the zeaxanthin, and then around it is the lutein. Is that how it works?
Um, I didn't go that fine to really tease out, but you'll find the zeaxanthin in the center, very center, because we did punches, and so the distribution of meso versus the zea, I think, is about the same. But what the point being is that zeaxanthin, most of what's in the center is zeaxanthin and mesozeaxanthin, and as you go out, more of it becomes lutein. So they're all important.
So if we tease them out, I know we look at them together, but if we tease them individually, what function does meso have? What function does zeaxanthin have? What function does lutein have for somebody like for the public, for a general person? What do they do for us?
Well, I think they're all important, of course, and they all do the same things, but maybe differently. It may be structural, how they are presented in the cell membranes, where they're positioned. And so they have those functions of blue light filtering. There may be a structural function and an antioxidant function. So they're all doing the same things, but they may be doing them a little bit differently, in part maybe because of where they're positioned in the macula.
I wanted to tell you a story, and if you could help me with this, because I know that there's a lot of studies on this. I have a 13-year-old son who plays baseball.
Yes.
He takes a 10-10-2 supplement, meso, lutein, and zeaxanthin, and he rarely ever swings and misses at the ball. I can't say he always hits it hard, but he almost never swings and misses. And one of his teammates would swing and miss all the time. I would say 70, 80% of the time he'd swing and miss. He struck out almost every time up. And then he started taking this supplement, this 10-10-2 supplement with lutein, zeaxanthin, mesozeaxanthin in it. And he also took batting lessons at the same time. I want to say that, but his swing and miss rate is almost non-existent at this point.
Oh, wow.
And that happened to another kid on the team, which swing and miss a lot. And he did his lessons, batting lessons, has not changed. And his swing and miss rate has gone way down. Now, I know that Stringham has done a lot of studies on sports, and I was wondering if you could tell us a little bit about visual reaction time and sports when you repigment the center of the macula. And I just find it fascinating because with my own eyes, I mean, I'm an eye doctor. I know what the research says, but research is one thing. But when you see it really happening, that really makes you pause. So tell us a little bit about the research that, I don't know if you've done any research with athletes or it's just Jim, but if you could tell us a little bit about that, because, I know in your circles, you know about this stuff.
Right. So one thing is, I'm thinking of 13-year-olds right now, right? Is that what you said? Your son is 13? Right. Okay. So not a lot of 13-year-olds are eating green leafy vegetables, right? So they're probably starting low. And then when you're starting to pack them with, 23 milligrams of these macular carotenoids, you're probably going to move that macular pigment level in the retina. And we know that it's important for prevention of AMD, but it's also important for visual function. So that goes, down in the lifespan to include both younger people as well as the older people. And there are studies, as you mentioned, by Stringham and Hammond, who have looked at visual acuity in sports such as baseball to find that you do get a quicker reaction. You see the ball better and so on. So now we're kind of getting into not only vision, but cognitive function, reaction time, where a lot of the research in the past few years has gone, given that the eye is part of the central nervous system and it's the neural tissue. So this visual function, cognitive function are pretty much intertwined, that it could help with something like a better swing.
It's really very fascinating. So I did want to ask you about that. So getting back to carotenoids, carotenoids are broken up into xanthophylls and carotenes. Can you explain to us the difference? And is it important for us to know the difference?
Well, they are different, and that's why you have the two classes. So what carotenes are, some of the more popular ones and major ones that are in our foods are beta carotene, which you find in your winter squashes like pumpkin and Hubbard and butternut, and carrots, and lycopene. So that lycopene is mostly in something like tomato and tomato products, and it's red. So you can easily spot your vegetable as having lycopene if it has some red color to it. Now those are carotenes, and they're carotenes because they don't contain an oxygen, and so it's just really made up of carbon and hydrogen. And whereas the xanthophylls, such as lutein, such as zeaxanthin, there's another one called cryptoxanthin, which you find in mangoes, for example. Those will contain an OH group, an oxygen hydrogen group on the molecule, and they tend to be more polar, and what I mean like that, both groups are fat soluble, okay? And fat soluble means if I would sprinkle my lutein or beta carotene into olive oil, it would disperse and dissolve. But if I took those two carotenes, which are fat soluble, and put them in, a glass of water, they'd float to the top, just like when you mix oil and vinegar, right? So they're both fat soluble, and that's why they like to go where fat is, and the central nervous system is pretty fatty with a lot of fatty acids and cholesterol and all that. And so they go there, and but because of this OH group that you find in the xanthophylls, they travel differently in the body. So in the body, all carotenoids travel on something called lipoproteins. So you may have heard of LDL, HDL. Now, when you go to get your physical every year, they'll do your blood test to see what your HDL, LDL levels are. And that's the only way carotenoids get anywhere, is traveling on one of these lipoproteins. There's others too, but those are major ones. And because of this OH group I talked about that xanthophylls have, they're distributed differently among these lipoproteins. They tend to be more in the HDL, that's the good cholesterol, whereas the carotenes tend to be more in the LDL, the one that you pay close attention to when it comes to risk for heart disease. And that's because of this OH group. They like to be on the outside of this glob of lipoprotein, and they travel different places. And that's why we don't know, why you get lutein and zeaxanthin preferentially taken up into neural tissues, such as the eye, such as the retina and the lens, such as the brain, because of it traveling on the HDL. It's more likely to get taken up because of that.
The question is, I'm sure everybody watching this is going to ask, okay, now I think a quarter of the population over 40 is on a statin. And if you lower your LDL and your HDL too low, are you not going to be able to drive these important carotenoids to the parts of the body where they need to be, such as the xanthophylls into the eye, and the carotenes maybe into the heart, and prevention of cancer?
That's a really good question. And I can't think of a reference that I could point to answer that question. What I do know, that's not all statins are alike, right? And some of them do actually cross the blood-brain barrier, and some of them don't. And I'm not sure if that would make a difference, but I can't answer that question for you.
MacuHealth, your science-born and tested solutions for visual performance, macular degeneration, and dry eye syndrome. New products coming soon. Embrace the science.
I mean, it's a theoretical question because
Yeah.
with certain heart patients, they want to drive that LDL down to as low as they can, to 60 or 50, and the total cholesterol to 100. And if they do that, cholesterol is part of the immune system, and are we going to be able to get these carotenoids into the eye? Of course, we
Yeah.
don't want to die of a heart attack, so I guess you got to weigh pros and cons. It's a
Yeah.
philosophical question.
And I think what's more important is that ratio of HDL to the LDL. I think that may be more important is looking at that ratio. But yeah.
So you brought up an interesting point before about all these different colors. Diana Menich, I think is how you pronounce her name. She wrote a book, or she talks about something called the rainbow diet, having a lot of different colors in your diet. And because each color you're getting different types of carotenoids or vitamins and minerals. How do you feel about that?
Well, I think that a diverse diet is a good one. The more different things you eat from the various food groups, so get all those fruits and vegetables, get your protein foods, get your whole grains, because it's not just lutein that's going to give you optimal health. There's a lot of these things in our diet called bioactives. Some call them phytonutrients that you find in plant foods. We talked about hundreds of carotenoids. There's thousands of these phytochemicals that are important for health. We may not be able to find out what they're all doing, but again, the more diverse your diet is, the more likely you're going to get a variety of these phytonutrients, and the more likely, it's going to help you out with optimal health. And so your berries, will have something called anthocyanins and the flavonoids. And so those have been shown to be important for decreasing the risk of heart disease and related to cognition as well. Whole grains, we think of, healthy bowel function and heart health as well. So they're all doing their part, and they don't act alone. They really work together. And it's important to just get that variety of foods.
There's been studies about carotenoids decreasing the risk of heart disease, decreasing the risk of cancer. Can you comment on that?
Yeah. And so what you look for when you want to look at the strength of the scientific evidence is, one, consistency among different research groups, so that they're all kind of finding the same thing, and consistency among study designs. So you have your epidemiology, which I talked about. I talked about your randomized controlled trials that kind of get, controls for some of the variables that you would like to control for. And you have some mechanistic work to really understand how these things are working. And so that's, going to the lab and the test tubes and figuring out, do they have antioxidant function? Are they important for inflammation, and so on and so forth? And when it comes to lutein, it does pretty well. I talked about biological feasibility early on, when knowing that it's an antioxidant, noting that the eye is vulnerable to oxidative damage, light damage. So we have that kind of mechanistic work. And when we do our studies in animals, we find that when they're fed lutein, they do better when it comes to visual function. And then we have our randomized control trials. We have many of those that have looked at visual function. The placebo group, you don't see much change. The lutein group, you see an improvement in visual function. And then we have the epidemiology, which you look at these large populations, a real world situation, and you find that those people who are eating their carotenoids, their green leafy vegetables, are at decreased risk of age-related macular degeneration.
And would you also say cancer and cardiovascular disease?
Yeah, same thing. And yeah, it's same thing. You see that with carotenoids as well. Those studies have been done.
And is there a difference in the carotenoids for cancer and cardiovascular disease than the eye? are the different carotenoids that people should be eating. So
Well,
lycopene, is that more important when it comes to heart and cardiovascular disease, where the I is lutein, zeaxanthin, mesozeaxanthin? Is it matter?
well, lycopene, the one that jumps out is a prostate cancer, and those studies have been done, and that's a lot of the epidemiology to say men who consume tomato and tomato products have a decreased risk of lycopene. Beta carotene has been looked at for cancer prevention, and that's in part because beta carotene is a precursor to vitamin A. So if you're a vegetarian, you're not getting your vitamin A from your glass of milk, and you're not getting it, from these animal products. But you are getting it from your carrots or your winter squash, or there's some in spinach as well. And that beta carotene, when you eat it, can become vitamin A. Now, talking about vitamin A, the research knows that it's important for cell differentiation, and it's important for integrity of epithelial cells and so on. So it was looked at way back when. I can't remember when these studies were. They might have been the late 1990s or so. The idea was you looked at the epidemiology, and people who are eating carotenoids, beta carotene specifically, were getting less lung cancer. So then the big idea was, okay, if that's true, let's just supplement with beta carotene and see what happens as far as lung cancer in people at high risk for lung cancer, that being smokers and asbestos workers. And what they found was, when you supplement people at high risk for lung cancer, smokers and asbestos workers, at pharmacological doses of beta carotene, they actually got more cancer. And the reason for that is, you're going beyond what's in the diet. So that really points to get your stuff through diet is a good idea. And when you're going to this pharmaceutical level, that beta carotene likes to go to the lung, and it becomes a pro-oxidant. So it's in that environment of a heavy smoker, you actually get more lung cancer. But again, pointing back to the epidemiology, when you look at dietary intakes of beta carotene, you don't see this risk.
So at what level of milligrams with artificial beta carotene does that risk start with the smoker and lung cancer? Because most multivitamins probably have beta carotene in it.
Yeah, right. And it's not a concern of, certainly they would have, because it wasn't just one study, it was two studies that found this to be true. And they were like tenfold beyond what you can get in your diet. So it was really high. So like, I think it was like 50 milligrams every other day, whereas in your diet, you can get 5, 6, 7, it's, yeah. And again, I think coming from diet, you can't, that's a limiting factor. How much can you eat, right?
Well, that makes me think of the ARADS, the original ARAD study with the high dose of zinc, and people would get some side effects, urinary tract infections. I think it was about 18%. So I think, you need the right amount. You don't want to overdo it with these mega doses with certain supplements.
Right. And yeah, and it's pretty easy to get a dose of lutein through food. To give you an idea, so I did a study with frozen spinach, and I had the subjects eat like 2 ounces of thawed frozen spinach, 2 ounces a day, right? So that's not a lot. That 2 ounces of spinach. So think of that 10-ounce pack of frozen spinach. That's going to last you a week, though. And that 2 ounces contain 10 milligrams of lutein, which is that you look at there's a survey in the United States called the National Health and Nutrition Examination Survey, or short for NHANES. And you look at NHANES, and it's a survey of what the general population is eating. And so you can see what the general population is eating in terms of lutein and zeaxanthin. And the average amount that people are eating in the United States is 1 to 2 milligrams. But if you go to like the 97th percentile, so that top 3%, it's about 10 to 11 to 12 milligrams. So it's certainly a dietary level that can be achieved. And the epidemiology suggests that it's about 6 milligrams a day that's related to decreased risk of AMD. And that work was done by Johanna Seddon in 1994. So that's when lutein became, of interest, is way back then. And people just jumped on that bandwagon to look at what was going on with lutein in eye health. And since then, a lot of work has been done. And it's, as I said, it's been pretty consistent among different research groups, among different populations. And as far as what we know about mechanistically it can do. So it's really, I think, pretty strong support that lutein's important for visual health.
I think Joanna Seddon's original research, really set the bar, set the tone for future research, as you said, for decreasing your risk of macular degeneration. So if you could, tell us a little bit about some of the research that has happened to decrease macular degeneration from lutein or zeaxanthin or lutein zeaxanthin, mesozeaxanthin. What do we know? What do we know for sure? So you're one of the problems with researchers and doctors. So I'm in the clinic and I'm seeing, 20 patients a day, maybe 25 patients a day, but you are doing research and I'm taking your research and I use that knowledge to help my patients. The problem is it takes about 17 years for what you do to reach what we practice in clinic, unfortunately. And I like to see if we could somehow shorten that amount so the public could get better information. So, but with that being said, if you could kind of review about lutein, zeaxanthin, mesozeaxanthin, or the carotenoids in general, decreasing the progression of macular degeneration. What do we know? And it doesn't have to be AREDS too. It could, there's been a lot of studies that are non-AREDS that have shown that lutein decreases the progression of macular degeneration, that zeaxanthin decreases the progression of macular degeneration. So tell us some of the studies. What do we know about this for the doctors listening, for the patients listening? I see a patient with some drusen. They have a family history of macular degeneration. I want to be able to give good advice to my patients. What do I do? And what does the study show us?
Well, the evidence, everything I know supports that. One, it talked about mechanistically what we know about lutein. Two, we know that it gets preferentially taken up to where it needs to go, into the macula. And you can increase that amount pretty easily through diet. I did a study with that spinach I was talking about, and in a month you see an increase with 2 ounces of spinach a day. You see the studies that look at visual function, the well-designed studies that looked at visual function, and you see that it actually helps improve it. So we have the human data, we have the mechanistic data, we have the epidemiology data, and the advice is simple. It's just look at what you're eating and incorporate these carotenoids into your diet. It's really about the fruits and vegetables, because it's not just about lutein, it's about other things you get in your plant foods, like the vitamin C. It's the beta carotene may be important in terms of an antioxidant function, even though, just the whole systemic antioxidant status. And as you well know, that, AREDS 1, where they looked at zinc and copper and beta carotene and vitamin E. here is just this nutritional supplement that actually delayed the progression of AMD. And that's like huge, because here you're talking about disease that there's no cure for, right? So what's the idea? So you try and slow that progression down, and so how can you do it through what we know about our foods, our nutrients, what happens in the eye? And so the dietary advice is there. So ARES 1 did so great that they decided to do it all over again. And they did it all over again when they looked at, okay, these people that did well, what were they eating? And two things popped out. They were eating lots of lutein, and they're eating a lot of these omega-3s, your fish oils, right? And that makes a lot of sense, because lutein and these fish oils have a lot in common, and it makes sense that they work together. I told you lutein gets preferentially taken up into the eye. And the major polyunsaturated fatty acid you find in the eye is your DHA, your docosahexaenoic acid. And those are the things that the people were eating. They're eating their fish and they're eating their green leafy vegetables. So they did the study all over again. And then you may know that design. It's a lot of arms to the design, but they looked at, can we replace the beta carotene with lutein, because of this idea that lutein may be a risk for those at risk for lung cancer? Can we, they lowered the zinc to see if that would be helpful. And then they looked at, adding the lutein, and then they looked at the omega-3 as well. And what they found is that, yes, you can replace that beta carotene in the ARES 1 supplement with the lutein and zeaxanthin, and these people are gonna, it's gonna help decrease that progression of AMD.
One of the things that I saw with Joanna Seddon's study, which really people don't really talk much about, but I thought was fascinating. It showed the arm with the smokers that ate high amounts of foods with lutein in it. They didn't progress, even the smokers. And I thought that was pretty fascinating.
Yeah, and Johanna's was an epidemiologist, said there was no supplementation, so they were getting dietary levels of this. Yeah, it's when you start getting really high, that's when you might want to be careful.
Not that we're recommending smoking, but
no,
but it mitigated it. And I don't know how long it would. I don't think no one knows how long it would mitigate it for. I think it was 5 years or something. We don't know what happens at 10 years or 20 years, but it did mitigate it for about 5 years. And I thought that was, that was pretty incredible.
Yeah.
I do want to ask you this. I one of my podcast guests is a brilliant cardiac thoracic surgeon named Dr. Phil Ovadia. And he was an obese cardiac surgeon, and he changed his diet to a carnivore diet. And when I was on his podcast, he asked me if I eat, since animals eat grass, would that increase macular pigment and decrease the risk of macular degeneration being on a carnivore diet? And I didn't know if that was ever done. And if you're eating meat, if you're just eating meat, will that increase macular pigment? Since the animals are eating grass, they're eating.
Well, I would look at that hunk of beef, and is that the fat around it yellow? It's not, right? It's white.
Right.
Yeah. Whereas with the chicken, you see the yellow there. And the egg yolk. Egg yolk is a great source of lutein, believe it or not. We talk about plant foods and carotenoids being in plant foods, but the egg yolk is yellow because of lutein and zeaxanthin, because the chickens are eating corn, and corn is another source of these two carotenoids. But you don't get a lot of carotenoids, hardly any, in animal products. It's really going to be your plant foods. Because if we didn't have carotenoids in the world, we wouldn't be here, because carotenoids are essential for plants to grow, because they protect them from light damage. And they have other functions as well. So we wouldn't be here without carotenoids. So that's where you're really going to get it. And it's pretty easy to find, if anyone's curious about how much they're getting. The USDA has a database that of I don't know how many foods, tens of thousands, and you just click in your food and you can find how much lutein and zeaxanthin you're getting. But if you're eating your green leafies, you're eating your broccoli, your peas, your corn, you're going to be getting a dose of lutein and zeaxanthin for sure.
And my understanding is in Mexico, they put mesozeaxanthin in the feed because people like very yellow yolks in Mexico. They don't do that here. Maybe that would be helpful here because depending if it's pasture raised chickens you're getting your eggs from, there's a big difference in the density of the yellow of the yolks.
I believe it. Yeah, I believe it. And the egg yolk is a terrific way to get lutein and zeaxanthin. The study that I did looked at how much lutein in spinach, a supplement, an egg, how much of it actually gets absorbed in the body. And that's something called bioavailability. It's what's in the food actually ends up in the body. So all these groups had the same amount of lutein. It was 6 milligrams, whether it be an egg, whether it be in spinach, whether it be in a supplement. And then they ate we put it in a frittata, and then they ate their frittata. So it was frittata with just egg white and spinach, a frittata with egg white and supplement, and a frittata with the eggs. And then looked at when it appeared in the blood. So then it got absorbed from the gut into the body. And the egg yolk did 3 times better than spinach, and 3 times better than the supplement. And the supplement and the spinach did about the same. But the egg yolk, the lutein just slid right into the body. And the reason for that is that in the egg yolk, you have something called phospholipids, and they help lutein be absorbed into the body. And so it's a different vehicle that it's in. It's just different. And so, I did a study with egg yolk, and we were able to increase, I think they ate 2 eggs a day for 6 months, and lipoproteins didn't budge with that. We checked that, didn't budge, but their macular pigment increased significantly.
So when you eat foods that have lutein, such as spinach, kale, collard greens, should you eat it with fat? Should you eat it with olive oil? Should you eat it with butter? Should you eat it with some kind of fat to get it to be more bioavailable to the body?
Yeah, that's a good idea, to have your spinach salad with olive oil, because early on in our conversation, I talked about how these carotenoids are fat soluble. So if I took a lutein supplement and got it down with orange juice, it's probably not a good idea because there's not a lot of fat in orange juice. So lutein, we eat it in milligram amounts, right? And we eat fat in gram amounts. So that's 1,000 times more, right? We eat 1,000 times more weight of fat than we do lutein. So to take 6 milligrams of lutein without any fat, the GI tract doesn't recognize fat coming in, so it's not going to push out the bile salts. It's not going to push out the pancreatic juices into the gut to get that piece of fat soluble component absorbed from the gut into the body. So you need enough fat so that the GI tract recognizes, okay, here comes some fat. Let's make sure we package it so it can be absorbed through that epithelial cells into the circulation. So that's why it's good. You don't need a lot of fat. You just need some. In our study, when we looked at spinach and macular pigment, eating 2 ounces of spinach a day, we instructed them to just do it with like 2, you get those little slabs of butter. It's like 5 grams, I think, like a slab of butter, or a teaspoon of olive oil, just a little bit of fat, and it was fine. I mean, macular pigment went up with just a bit of fat. So it's not like you need to eat a stick of butter. You just need like a teaspoon or a tablespoon, not a tablespoon, that's a lot. Just a little bit, so that the GI tract recognizes fat coming.
Your eyes and your vision are under attack, damaging blue light from the sun. Your phone, your computer, your tablet, even light bulbs and car headlights is constantly bombarding you. The good news is our eyes actually already have a line of defense to counter the effects of blue light. This defense is made up of 3 pigments called carotenoids. MacuHealth with Micromicelle, the only supplement with the exclusive patent on all 3 macular carotenoids and Micromicelle technology.
Fitting multifocal contact lenses presents a big opportunity to meet patient needs while growing your practice. Alcon is your partner not only with our innovative portfolio, but through e-learning. Learn to enhance your multifocal strategy today with the Alcon Experience Academy.
OIE Broadcasting is the emerging leader in social media. We use scientific entertainment to drive more patients into your office. Visit oiebroadcasting.com and sign up today.